Hi, this is a quick explanation of how our Anti DDoS SDK works, right? So first of all, why we need an Anti DDoS with the client-side SDK integration, right? Because you know that most of the time there is a difficult for this Anti DDoS engine to like identify to detect those like UDP based attack, right? Because it's signatureless, it's patternless, especially for example the gaming use cases or for like web streaming use cases. I mean, most of the traffic is pretty random, right? So it's running on, for example, the random UDP ports, and most of the time it's signatureless, it's patternless, and in terms of the efficacy of the anti DDoS engine, right? So it can't go as high as 100%. However, but with the Tencent Anti DDoS SDK solution, which we can use them to boost the efficacy of the anti DDoS scrubbing to close to 100%. Why we can do that, right? It's like with the client-side integration over here, where all the traffic being sent out by your client-side application, for example, your mobile app, right? For example, your PC app, will be labeling all those egress packets or outgoing packets with a certain dynamic label using the algorithmic approach, so that once the packet reach our Tencent Anti DDoS engine on the cloud, right? Because the server is sitting on our Tencent cloud that is behind the Anti DDoS engine or the scrubbing engine. And this particular Anti DDoS engine is going to recognize the particular watermark that has been labeled by this client-side SDK together with app data. And then for this particular Anti DDoS engine, it's going to accept the traffic or the packet being labeled by this dynamic watermark on a per packet basis and drop all those packets that is non-labeled, so that we can achieve the efficacy close to 100%. It's really effective. It's being used by all those popular games like PUBG Mobile, League of Legends, etc. Right? So with that, I'm going to walk you through on the details. Right? So basically how it works. Right? As I mentioned earlier, right, why the efficacy could be as close as 100% is because all those attack traffic without watermark is going to be dropped by our anti DDoS cloud-based scrubbing engine before it reaches the TCP UDP server that is sitting behind the scrubbing center. So, of course, there's prerequisite for that, which is the client-side integration using the SDK. So basically, the SDK is enclosed or embedded into a DLL file, right? So that, I mean, inside your application code, that you need to load this particular library. And then this particular library that is called GIMSet actually contains a watermark generation algorithm, which is not disclosed to the public yet. However, how it works is basically it takes several input and it will generate output, right? So the output basically is the dynamic packet watermark. But what is the input value of that? Right? So first of all, is the buffer size. Over here, you only have two options, right? Because we provide you with two different type of the watermark option. One is considered a light one, and the second one is relatively comprehensive one. So there are two options can be taken. The first one is 8 byte, the second one is 20 byte, right? And the second, a third, is the server destination port and server destination IP will be taken as an input value for the watermark generation algorithm to come out with the output. And the last one is the most crucial one is the watermark key, right? So basically that is a string, right? And it will be synced with the one from the cloud anti DDoS console. So let me just walk you through the cloud anti DDoS console, right? So over here is the cloud anti DDoS engine console, and from here probably you can just select, for example, the protection levels, whether it will be strict, medium, loose, and over here, right, there's an option, right, for you to generate the watermark key, right? So click create, and then over here, as I mentioned earlier, right, so there are two different options. One is 8 byte, and the second one is the 20 byte. So the 20 byte is considered normal type, and the 8 byte, right, 8 byte is relatively smaller in terms of the header size. So that over here, I'm going to select a normal one, and over here, right, is the port range. So you don't want all your like packets, I mean, from TCP port 1 to like port 999 being scanned, right? You probably select specific range of the ports and the traffic to be scanned for this particular watermark. Of course, there's an option for you to scan all, but best practice is to like select a range of them, right? For example, 20 to like 29, just give it an option randomly. Of course, over here you can select UDP as well. And watermark offset, it should be corresponding to the watermark check move over here, right? So over here we have the 8 byte and also the 20 byte. So since I selected the 20 byte, which is a slightly bigger size, which is considered normal type, so over here by default I'm going to put 20, right? Otherwise, for example, you want to do like certain like customization, right, to your header to add more details into the watermark, that is also possible. But by default, since I'm adding nothing, then a watermark, so I'm going to put a 20 byte as default. So, and then I'm going to click OK. It's taking a while to generate the watermark, right? So you see that this is the IP being protected. This is the protocol port range that we instruct the anti DDoS engine, right, to scan to look for the watermark header inside the packet being received. And also this is the offset value, which is 20 byte, that is corresponding to the normal type, right? And you can turn it on and off. And here is the key configuration. And this is the key that is going to be synced with the client-side SDK. So it will be embedded into the client-side code, right? Of course, in terms of the key rotation, there's an option for you to add another key, right? So that you can do the key rotation on a timely basis. Of course, you want to get all the key delivery fully automated. That is also possible, because what you see have been like backed up by our API, right? So that you can retrieve the key, you can rotate the key just simply using the API. So you can achieve the full automation. So after it's done, let me go back to the slide over here, right? So over here, right? So the watermark key should be synced with the client-side code, and over here, right? So going to walk you through the code, right? So basically, this is a really, really simple demonstration code. Like basically, it's going to display the packet header information that includes the watermark in a sort of like integer format or decimal format, right? So over here, let me just walk you through the code, right? So basically, this is a C++ code, and after you run that, right, so you're going to see all those like packet being generated, but it will be represented in the sort of integer format, right? So over here that you see, this is a first packet, and this is a second packet, a third packet, right? So basically, this is a result of this particular code, but how it works, right? So you see the first thing that you need to do is to load the library, and which is the gameset DLL, right? So this file is accessible through our Tencent Cloud website. So later I'm going to share the link in the description. And over here, you see that this particular function is from the DLL file, is from this gameset library. And of course, first of all, you should basically do a check that whether the library, whether the like gameset DLL is inside your folder, right? So if not, then of course you can't run this application. And then they're going to like taking the input value, as I mentioned earlier, right, which is the four of them, right? Buffer size, server destination port, server destination IP, and also the watermark key, right? So basically, these are the four key components in terms of the input value. And if I go back to the code over here, then you see the first one is to define the buffer size, right? So the buffer size will be linked to here, right? Because we're going to loop for 20 times. So basically, I'm going to show you the first 20 byte of the packet that contains the watermark value. So this is the first one. It will be linked to here, right? And the second one is the destination port, and the third one is the IP address of that, And the fourth one is the watermark key, right? So basically it should be synced with the one that you just generated on the cloud console. Of course, automation can be done. For example, you create a separate server-side code logic. Once you launch this client-side application, the server-side is going to retrieve the latest watermark key and get it delivered timely or dynamically or immediately, right, to the client-side app, right, as a variable. So that is also achievable. Or alternatively, right, for POC purpose, we just simply hard code this particular watermark key, right, for the simplicity of a demonstration. And then over here, what I would do is to generate, for example, totally 10 packets. So over here later, you're going to see that total 10 liners over here represents 10 different packets that contains the watermark value. And then is, okay, how many bytes of each of the packet header you want to see. So over here is from 0 to 19, so totally 20, right? So I'm going to look for 20 times. So basically it will display the first 20 byte of the packet header value that contains the watermark as well, right? So what I'm going to do is, okay, I'm going to run this application, and the application is relatively simple. It's just like A. So I'm going to run it, right? So I'm going to generate the watermark, and we're going to like generate 10 packets. And I have to highlight that each of them, right, that you see from the code is represented in the integer 8, right? Which means that each of the value over here will take up a bit, right, inside the memory, right? So over here, for example, last 4 bytes that represents the sequence number, but how many options in total, right? It's not like 2 to the power of 4, it's actually 2 to the power of 32, right? Because each value, right, actually take up like a bit of the size, right? So totally, the sequence number can go up to like 2 to the power of 32 minus 1 in total, right? So I have to like quickly explain the structure of this packet header, right? Because over here is the 20 byte like packet header that is associated with the watermark value. So I'm going to like quickly explain the structure over here. So the first 4 byte is considered the initial factor, right? Basically, it will be fixed. And the second one, the second 8 byte, is considered the version identifier. Most of the time, it won't change. And the third one is the watermark value. So it changes packet by packet. Why we need to do that, right? We have to make it dynamic just in case those like packet replay attack. For example, the attacker trying to capture the packet details and they try to replay, they try to reproduce exactly what you have. What if, right, your watermark value is a static one? So over here, because of the algorithmic approach that we have, it's dynamic, right, per packet. And of course, last resort protection to protect you against those like packet replay attack is the packet sequence number. So over here, right? So we have a total of, possibility of 2 to the power of 32 minus 1, because each of them take up the 8 bit of the size, right? So basically, this is the structure of the packet header that is being generated by our watermark SDK. So the last thing I'm going to quickly show you is very interesting, but to prove to you that actually the first like 4 byte and the second like 8 byte of them actually most of the time it don't change. So what I'm going to do is I'm going to like quickly change the values over here, right? So for example, I'm going to change the destination port to like a 299, and I'm going to change the IP to 122, right? And I'm going to save it, and I'm going to compile this source code again. So it takes a while. Okay, it's done. And then I'm going to run the application again. You see, exactly the same as I mentioned earlier, right? So usually the initial vector and also the version of that actually don't change most of the time, unless, for example, you change the watermark key over here. I mean, the version of that probably will get changed. So this is the last one I want to show you to prove to you that actually the dynamic part It just last 8 byte of it. Includes the watermark value, it is the most crucial part, and the sequence number, mainly to protect against those packet replay attack. So this is all for my explanation of the Tencent Anti DDoS watermark SDK solution. Hope it's helpful, and also take note that this is the unique in the industry that's being implemented by all those popular games like PUBG Mobile, the League of Legends, etc. So thank you.